Determining mass percent. Well, mass percent is defined as an element's percentage of the total mass of a compound containing the element. All right? Mass percent is also called percent composition quite often, and rarely it's called mass percent composition. So usually you see mass percent or percent composition. All right, let's do an example for mass percent. C7H14O2, 130.21 grams per mole. This is from the previous problem, if you remember. So they're going to ask us something about C7H14O2 here. We want to find the mass percent. So we're going to need to know the individual mass contributions. So for carbon, 7 of them, there's 12.01 grams per mole for every carbon. We end up with 84.07. Okay? Well, the total molar mass is 130.21. The percent composition for carbon, or the mass percent carbon, is 64.6%. Hydrogen, 14 of them, each contributing 1.01 grams per mole for 14.14 total contribution from hydrogen. Divide by the total mass, you end up with 10.9% hydrogen. Now, since we have 3 elements in the compound, we can get oxygen just by doing subtraction, right? And those 3 boxes add up to 100%. So it's just that simple for mass percent, okay? Now, the largest topic for today, it's going to take up the rest of this, this video, is determining empirical and molecular formulas. Now, there's a process to this, and it's very simple if you follow the process. So, determining empirical and molecular formulas. Empirical formula is the simplest whole number ratio of atoms. Okay, it's not necessarily the actual formula. So empirical formula is the simplest whole number ratio of atoms in a compound. Molecular formula is the exact formula of a compound. That's what you would see written. All right. So moving on to the next page of our notes, just a little blip here on molecular formula. Molecular formula is actually, it's equal to a multiple of the empirical formula. So the molecular formula is equal to some integer n. And by integer, I mean 1, 2, 3, 4, etc. So the empirical formula multiplied by a factor gives us our molecular formula. That's just a bunch of mumbo jumbo. Let's just get straight to it, and we'll practice with an example. Examples always make the process much easier. Suppose a compound is 71.65% Cl, 24.27% C, and 4.07% H. Its molar mass, they're nice enough to give us, is 98.96 grams per mole. Find the empirical formula and molecular formula. Quite often they're going to ask you in the last sentence of these problems to find the empirical molecular formula. You always find the empirical formula first. Okay? So that's just a note there, a little star. Always find the empirical formula first. So step 1 on step 1 for finding the empirical formula. Assume you have 100 grams of the material and convert to moles. So if I have 100 grams, 71.65% Cl is 71.65 grams of Cl. 24.27% carbon is 24.27 grams of carbon, and so on and so forth, with the hydrogen down there being 4.07 grams. So I just line them all up, convert to moles, one step, boom. I get the following answers. 2.021 moles of Cl, 2.021 moles of C, 4.04 moles of H. Now step 2. Step 2 is to divide by the smallest number of moles. The smallest number of moles is 2.021. So that little step 2 I'm squeezing in there says divide by lowest number of moles. We end up with 1 mole of Cl, 1 mole of C, and finally 2 moles of H. Okay? Luckily, they all came out as whole numbers, roughly whole numbers, 1, 1, and 2. Step 3 of this process is to combine moles of each atom into an empirical formula. All right, so if you look up there, we have CH2Cl. You might be wondering why I started with carbon, and let's make a little note on why I did that. It says carbon is always first if all elements are nonmetals, and these are all nonmetals, so it's CH2Cl. All right? So there's our empirical formula. All right? Now, since we have to also find the molecular formula, right, we're going to need some more steps, not just 3 steps. 3 steps it took to find the empirical formula. So if you want to find the molecular formula as well, 2 additional steps are needed, and they're fairly straightforward. Number 4, calculate the empirical mass, right, or the empirical formula mass. Well, we have our empirical formula from the bottom of the last page of our notes, CH2Cl, 1 carbon, 2 hydrogens, 1 Cl. We add them all up on the periodic table, and as you know, I like to use the hundredths place. I come up with 49.48 grams per mole. Now, that is the empirical formula mass, or the empirical mass. We then use that boxed formula where we have molecular formula equals N, some integer, times parentheses empirical formula. Remember that box at the top of the last page? So we're going to plug the empirical mass and the molar mass into boxed formula from our notes. 98.96 grams per mole, molar mass, equals N times 49.48. We end up with N equals 2. So that's our multiplier. We multiply the empirical formula through by 2. The molecular formula and the actual formula of the compound is C2H4Cl2. All right, let's do another example just to hammer this home. A compound containing only nitrogen and oxygen, just 2 elements, is 30.4% nitrogen by mass. If the molar mass of this compound is 92 grams per mole, what's its molecular formula? All right, so it's asking us what's its molecular formula, but remember, we always have to calculate the empirical formula first. So that's what we're going to do, steps 1, 2, and 3. Assume 100 grams. So we have 30.4 grams of nitrogen, 69.6 grams of oxygen. Moving to the next page of our notes, what we're going to do is we'll line them up, 30.4 grams nitrogen. Below it, 69.6 grams of oxygen. Very important to include that all over 1. That's how we follow the units and cancel. Now, when we put the little over 1, we know that grams goes on the bottom. We end up with 2.17 moles of nitrogen, 4.35 moles of oxygen. Step 2, divide by the smallest number of moles, which is 2.17. We end up with 1 mole of nitrogen and 2 moles of oxygen. All right, step 3, we zip them together. We get NO2 as the empirical formula. Well, while we're here with the empirical formula of NO2, we might as well add them up and find the empirical mass, the empirical formula mass. 1 N, 2 O's. I always use a hundredths place. We get 46.01 grams per mole. That's the empirical mass. All right, well, they gave us the molar mass, or the molecular weight was 92 grams per mole, so it equals N times 46.01. Once again, in this practice problem, N is 2. We multiply everything through by 2. The actual formula, the molecular formula, is N2O4. Dinitrogen tetroxide, right? Remember that stuff, naming? Dinitrogen tetroxide. So question, gosh, what would happen if in step 2 up there, we divided by the smallest number of moles and we didn't get nice clean numbers? For example, what would happen if after step 2 above you had 1.33 moles of N and 2 moles of oxygen? You can't make it N 1.3302, right? Well, recognize that 1.33 moles of N is 1 1/3 moles, which is 4/3 moles of N. Remember, we're looking for lowest whole number multiples. So at this point, we would have the following. 4/3 mole of N, and 2 moles of O. If we multiply them through by 3, we get 4 moles of N and 6 moles of O as N4O6. All right, that would be our new fixed, improved, if you will, empirical formula, and then we could go from there. All right, so that little additional step happens when you have something like a 1.33 or a 1.67 or a 1.5, a 1.25, a 1.75. You see the example I'm doing right here. It says others besides something 0.33 moles of N. You could have 1.67 moles of N, which is 5/3 moles of N. You can have 1.5 moles of N, which you know is 3/2. And you just multiply by the denominator to get it to a clean number.